Question number 2 says 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5. How will we solve this one? Okay, the first thing that we are supposed to do is write the rth term. This here is T1, this here is T2, this here is T3. So what will TR look like? Let's take a look at this. T1 has this one, T2 has 2, T3 has 3, so TR will obviously have first term as R. Each term is product of 3 numbers, of which first is for TR, the first number is R. The next number is 1 plus 1, 2 plus 1, this plus 1 plus 1 plus 1 plus 1. So what you'll have is R plus 1, R plus 2. If you have any kind of confusion, please verify that whatever you have written is correct. Let's put R equal to 1. This becomes 1 into 2 into 3. Yes. R equal to 2. 2 into 3 into 4. Yes. R equal to 3. 3 into 4 into 5. Yes. Verified. That's okay. Yes. So TR has been written. Yes. And Sn will be sigma TR. Yes. What is this simplify into? Let's multiply them. R. This is R square plus 3R plus 2. And this becomes R power 3 plus 3R square plus 2R. Which method are you following? I am following the original method first of all, and then we'll see the other method later on. So I am following this. TR is equal to R power 3 plus 3R square plus 2R. Okay. Sn will be sigma TR from R is equal to 1 to N. What is that? Sigma of this expression. Sigma of R cube plus 3R square plus 2R. R is equal to 1 to N is what we are interested in, right? This is 2R. This is what you have. Now let's separate them out first. Let's separate out the 3 sigmas. This will be sigma R power 3 plus 3 times 3 is a constant that will come out common plus 2 times sigma R. Now, is it necessary that you write the limits of summation from lower limit to upper limit? Yes, it is very necessary that you should mention that in each and every step. But then, when we are solving the questions fast, especially for competitive exams, what you can do is, not in the board exams mind you, but for the competitive exams, for the time being, do you see that R is equal to 1 to N, that's supposed to be mentioned over here, but if you want, you can skip it sometimes. Don't skip it in the initial steps, don't, never. But this same sigma is translated over here, so we can skip that, right? What next? Sn is this, which tells me, okay, Sn will be equal to sigma R cube, that is n square n plus 1 square upon 4 plus 3 times sigma R square n plus 1 2n plus 1 over 6 plus 2 times n plus 1 by 2. You see 2 goes with 2, 3 goes here and this becomes 2. So in the numerators take the HCF. What is that? n plus 1, n plus 1, n plus 1 comes out common. In the denominator take the LCM, which is 4, comes out common. What remains is n plus 1 from here, which is n square plus n plus. What remains from here? If you observe, in the denominator you need to create 4, so you need to multiply with the 2 first of all. n plus 1 has gone, what remains is 2n plus 1 plus n plus 1 has gone, 4 was not there, let's multiply with the 4. This is what you get. Okay, this becomes n plus 1 upon 4 times, what does this simplify into? This is n square plus n plus 4n is 5n and plus 2 and 4, which is 6. This is what you get. N square plus 5n plus 6. This is n plus 1 is okay. This factorized to is factorized as n plus 2, n plus 3 upon 4. And that's my required answer for Sn. As you can see over here in this complete solution. But then sir, what about the other method? Can we solve this using another approach? Yes. TR is R plus 1, R plus 2. Yes. So let's see the other approach over here. TR is R plus 1, R plus 2. Very simple, yes. If you see, these three numbers are consecutive, right? These are three consecutive terms. So what will be the next term? Next term will be R plus 3. What will be the previous term? That will be R minus 1. Subtract them and divide by whatever you have multiplied with. So R plus 3 minus R will cancel. Minus or minus 1 will become 4. So this is multiplication by 4 and division by 4. This is what you get. So this TR is 1 by 4 times, multiply this R plus 1, R plus 2, R plus 3 minus 1 by 4 times this multiplied with this. This is what you get. TR is this. Okay. Once you obtain TR like this, can you easily find the summation by writing T1, T2 and ... Tn? Yes. It has been written as difference of two terms, right? So T1 is 1 by 4, R plus 1, R plus 2, just a minute, T1. For T1 we don't need R, you will have to replace with the actual numbers over there. So T1 is 1, 2, 3, 4 minus 1 by 4 times 0, 1, 2, 3. T2 similarly will be 1 by 4, 2, 3, 4, 5 minus 1 by 4 times, for 2 R minus 1 will become 1, 2, 3, 4 is what you'll have. Is that okay? Yes, that looks okay. And once I reach this stage, I can observe, okay, these get cancelled. Similarly, this will get cancelled with the next ... Tn, what is Tn? 1 by 4, n plus 1, n plus 2, n plus 3 minus 1 by 4 times n minus 1, n plus 1, n plus 2. Yes or no? This is what you'll get. And yes, this gets cancelled. Okay, so what remains is Sn, which is the sum of all of these, that is equal to this minus this, which is 0 actually. So this is 1 by 4 times n plus 1, n plus 2, n plus 3. Is that okay? Yes. That is my final answer for this question, as you can see over here. Is that all? Yes, that's all in this question. And that's how you can solve it easily. Yes. Okay. Instead of doing what we just did over there, you obtain the same result, right? 1 by 4 times n plus 1, n plus 2, n plus 3. Is that okay? Yes. Can we discuss something else over here as well? Yes, we can discuss one more interesting thing. What is that? Let's come back to that black screen that we had. If you observe TR, R plus 1 is what we had, right? That implies Sn will be equal to, what was that? n plus 1, n plus 2 by 3. This is what we obtained in the first question. When TR was R plus 1, R plus 2, what does that give me? Sn is equal to, in this question, question number 2, n plus 1, n plus 2. N plus 3 also came up, and divided by 4 is what you obtained. Not only that, if I go one step back, do you observe that TR for R? If TR is simply R means 1 plus 2 plus 3 plus 4 plus ... up till n. For that, summation is already known, that is n plus 1 by 2. Summation of first n natural numbers. Do you see some kind of a pattern? What kind of a pattern are we talking about? I'm talking about, okay, this is R. What about the next term? R, instead of R, we see n and the next term n plus 1 and divide by 2. For R plus 1, we see n plus 1. Next term will be n plus 2 divided by 3. For R plus 1, R plus 2, we see n plus 1, n plus 2. Next term n plus 3 divided by. Okay. So in case you encounter TR is equal to R plus 1, R plus 2, R plus 3, r plus 4, maybe something way beyond, let's say, or r plus 5 as well. If you have this, can you write Sn for this? Do you see the pattern? Yes. So Sn will be, first write this, n plus 1, n plus 2, n plus 3, n plus 4, n plus 5, and next term, which is n plus 6, and divide by the number of terms 2, number of terms 3, number of terms 4, similarly number of terms 7. This particular question, although you will not encounter this question in general, but in case you see this question anywhere, you can directly write this answer, yes or no. Yes. Now you can do that. This is for this particular special type of general term TR, right? So that's all that you have in the second question. And is that all? Yes. In second question, that is all.